The whole reason why we are going through this trouble of designing and conducting proper research is to establish validity. Validity is the best available approximation to the truth. There are three types of validity. External validity is the extent to which your inferences can be generalized to a larger population, to different people, at different places, at different times, and it is determined solely by population sampling. If you take a good sample of the larger population, then you can make inferences back to it later. Internal validity is the approximate truth about inferences regarding cause and effect relationships in your study. It is determined by how you make assignments to groups, the treatment group or the control group. And finally, construct validity is the extent to which your measurements actually support the concept or theory behind it. You can kind of think about it like face validity. Now, generally, the whole point when conducting social research is to establish a cause and effect relationship that can be applied to a larger population. However, external validity may be hard for us to establish here at Primavera simply because each teacher only has access to his or her own students. In my example, I would only be able to generalize back to my Algebra 1A students. Notice how I was not able to sample all Algebra 1A courses, thus a random sample was not obtained. However, that is perfectly fine when making individual SMART goals. No one's asking you to make inferences to larger populations other than your own. Now, what we are concerned with is an internal validity. You can have internal validity without external validity. Internal validity and construct validity will be our primary focus when conducting our research here. Internal validity is only relevant to the specific study in question. All that internal validity means is that you have evidence that what you did in the study caused what you observed to happen. So what if I can't randomly assign participants to groups? Does this mean I can't establish a causal relationship or determine if there was a treatment effect? In other words, to establish internal validity? The answer is no. You can still establish this relationship to various strengths and confidence levels by reducing validity threats and eliminating what we call plausible alternative explanations. The strongest way to do that is by reducing threats due to design. We'll discuss some of these other ones in more detail later. So what if you want to study treatment effects using a single person at a time and not a group? Because that's a likely scenario here at Primavera. Or what if you have a small sample size? Another likely scenario. Can I still establish a causal relationship? Can I still reach valid conclusions? And the answer is yes or no. It depends on how small an effect you want to be able to detect and who or what you are making the inferences on. Although external validity may be low, you can still achieve good internal validity for those individuals or groups in your study. For example, you will not need a large sample size to determine if an intervention resulted in an observed 25% increase. But if you are trying to establish that scores improved by 5%, then your sample size would need to be larger. That is because a mere 5% increase could easily happen by chance, especially if you were just measuring a few students. So you would need a larger number of students to show that. However, we will be looking at designs called single subject designs, which will allow you to still establish internal validity in regards to individual students. All right, so time to discuss the specific threats to internal validity and how likely those threats are given different design scenarios. Let's look at the design scenarios on the right. So option one, a single group post-test only design. So that means you have a single group, the treatment group. You give them an intervention and then you give them the test. Let's look at these threats to the left and see how they might apply. Now, the biggest issue with a single group post-test design is that I can only state that students reached a certain level of achievement. I can't be sure that the students would have reached that achievement level without my treatment. I can't measure gains without a pretest either. It might be okay if you are looking at results of a standardized test like the SAT or SAT and you randomly selected participants and or you have good reason to believe the students have no prior knowledge of any of the tested material. So let's take a look though at a history threat in regards to a single group post-test only design. A history threat is an historical event that occurs in the course of a study that affected the outcomes. So suppose a free and advertised online SAT program became available and you were conducting a study or you're doing a program on SAT, improving SAT scores, and then this free program becomes available in the middle of your study. Then you wouldn't know if it was your program treatment that resulted in the achievement or the online program. This could happen at Primavera if, say, an interventionist was hired in the middle of your study and then some students or some participants started utilizing that interventionist. Now you don't know if it was your intervention or what the interventionist was doing that caused the outcome. A maturation threat is the natural maturation of students over time affects some outcomes. So the distinction between this threat and a history threat is that it's not a specific event, but rather all those other factors associated with the natural maturation of students over time. Now our classes are only 6 weeks long and this threat should be minimized. However, it could happen with, say, new students as they learn about taking online courses, how to navigate, find resources as they become more familiar with the structure of our curriculum. Again, this threat should be minimized depending on how much time passed between the treatment and the test. A testing threat, that occurs in a pre and post-test design. A testing threat means that the pre-test primed the students for the post-test. An instrumentation threat means that the instrument of measure was inconsistent, and that is especially true when the instrument of measure is a person. So a computer-graded test should not pose an instrumentation threat. However, teacher-graded assignments or projects are susceptible to this threat. That's why it would be very important to closely follow the rubric. A mortality threat, means that students are not dying literally, but dying from your study or dropping out. And this is particularly dangerous when the dropout is not uniform or homogeneous. We'll talk more about that later. But consider, for example, if only the poor performing students were dropping out, and then you measure the outcomes, they would be artificially inflated. And then finally, we have a regression threat, and that's when the group assignment was asymmetric when compared to the mean of the population. So another way to think about it is you can only go up from here, or maybe you can only go down from here. So this occurs when the treatment was given to, say, very low performing students or very high performing students compared to the rest of the population. And as what would happen is those students tend to regress towards the mean, which is very likely to occur with or without your treatment. So with option one, you wouldn't even be able to detect if this occurred because without a control group or pretest, it isn't possible to show that the selected students aren't somehow special. Let's take a look at option two, the single group pretest post-test design. Now all the threats we went over still apply, but with the presence of a pretest, it would now allow you to measure gains. So before you couldn't measure gains, now with a pretest you can measure gains. It would also make it easier to detect these threats and to what extent they impacted your study. So consider mortality, for example. Since you have a pretest, you can discern if the dropout was homogeneous or if only the low students were dropping out. The same applies to the regression threat. For the two-group or multi-group designs, every single one of these threats now do not exist. In fact, now they only exist as selection threats. And selection threats are multi-group threats that occur when the treatment and the control groups are not equivalent. So consider a history threat. If a historical event occurred, it should impact both the control and the treatment groups equally. Therefore, in the analysis, we can still determine if a treatment effect occurred, regardless of the historical event. A critic would have to argue that the historical event affected one group differently than the other. And if your groups are relatively equivalent, then this is a very unlikely occurrence. The same reasoning can be applied to all the other threats. Sure, we have a mortality threat here at Primavera, but if you have groups that are equivalent, then you only get in trouble if somehow the groups were unequally affected by the mortality threat. Just like the single group designs, adding a pretest, so now option 4, the two-group pretest post-test design, reduces these selection threats even further, because if the groups were not equivalent, you would be able to detect that difference in the pretest. Then, a qualified statistician would actually be able to make adjustments in the analysis to account for the confounding factors. So have you ever heard a researcher say, the mean improvement after adjusting for income or some other factor was blank? Well, a multi-group pre-test, post-test design is what makes that possible. Finally, we'll talk about construct validity. And again, that's the extent to which the measurements actually support the concept or theory behind it. And it does have to do with how you operationalized your study and if your measures are an appropriate way to judge the outcome or make inferences. So consider the example below. Suppose I was studying how parent involvement affects graduation rates, and one of my measures was parent income level. My critics might argue that parent income level is not an appropriate measure of parent involvement. Instead of parent involvement, I was really studying what role parent income played in graduation.